Welcome to the calculus class. We've spent a lot of time studying convergence tests for different series. Now, we move to the special kind of series we call power series, where each term has a power of x. What we're going to study this session, define and identify a power series. What is the center? Second, find the radius and interval of convergence using ratio test. Third one is express the interval of convergence clearly using interval or inequality notation where power series converge. Before we start definition of power series, let's have intuition. Look at the geometric series. Left is 1 over 2 nth power. Right is negative 1 over 2 n. Both are geometric series. Left one, guys, left one. This one is what is ratio? Ratio gonna be 1.5 between the negative 1, positive 1. This is converse. How about right one? What is ratio? R is negative 1.5. This also converse because ratio is between negative 1 and positive 1. But what if we're gonna replace ratio with x? X gonna be a known number. We wanna know which x value make this series converse or diverse. This one is we call power series. Let's get started with the definition of power series. Power series looks like this. We call this power series centered at C. Let's give the definition of each. An we call coefficient. X, C gonna be, we say center. X gonna be variable. We call this is power series centered at C. Let's expand this series. N equals 0, n equals 1, n equals 2. N equals 0, power gonna be 0, x minus c gonna be 0, x minus c, 0 power gonna be 1. Second, n equals 1, a1, x minus c. N equals 2, a2, x minus square. N equals 3, a3, x minus c cube. So on. This is infinity series with variable x centered at C. We call this power series. There is a very special power series centered at 0. So let's see this one. That's the power series centered at C. C gonna be 0, which meaning is summation n equals 0 to infinity an xn. That's what we call power series centered at 0. Let's expand this series. N equals 0, n equals 1, n equals 2. N equals 0 is a0 plus n equals 1, a1x, n equals 2, a2x squared, so on. Look at this power series. Looks familiar? This one is part of polynomial. Let's have first example, which is power series at center is 0. So look at this power series. This one is power series because part of x. I'm gonna rewrite the power series. 1 of n factorial xn. this power series center gonna be 0. That's the formal power series center is 0. Before we finding an, let's expand the power series. N equals 0, 1 over 0 factorial x0. x0 is 1, 0 factorial is 1. That's why first term is 1. N equal 1, 1 over 1 factorial, that's gonna be 1, x once. That's the x, so on. So what is the center? Center is 0, an is 1 over n factorial. Let's have another example. Summation xn. So what is an? What is the center? Center gonna be 0. An gonna be what, guys? Let's expand it. So 1 plus x squared x cubed. What is coefficient of each term? That's gonna be 1. So an gonna be 1. Let's have different example for power series, which is center is not 0. So look at this one, summation negative 1 and x plus 1 nth power. So this form looks like an x minus c nth. So center is c. What is the center of this power series? What is an? So when you expand this power series, that's the alternating power series. Alternating because sign is alternating. 1, negative 1, power is 1. Positive x plus 1 squared. You find the center is negative 1, not 1. Very careful. X minus c nth power. Here is x plus 1. C gonna be negative 1. Coefficient gonna be negative 1 to the n. Let's make sure, guys. Let's have another example. Look at this power series. Rewrite this power series. 1 over n times x minus 1 to the n. So what is gonna be center? What is an? Here is expand the power series and equal 1 x minus 1 once 1 equal 2 1 over 2 x minus 2 2 and equals 3 1 over 3x minus 1 cube. So what is the center? Center is 1. An is 1 over n. So look at this first example is x plus 1, center is negative 1, x minus 1, center is 1. When you have power series, here is the equation. Which x value make this power series converge? But here is the good news. We have a theorem about the convergence of power series. How do you know about convergence of power series? The first one is series converge only one x equals c. X is not c, not is a center value. That series gonna be diverse. That's the first possibility. Second, series gonna converge for any x value, all your number. That's the second option for the convergence of power series. Third option gonna be series gonna be converged if x minus c, absolute value x minus c less than r. Absolute value x minus c greater than r. That's gonna be diverse. But if x value is absolute value of x minus c equal r, we don't know the series converge diverse. Especially r is gonna be greater than 0. We call r is radius convergence. Power series only 3 possibility where series gonna be converged. Only 1 point, all your number. If you know the r, absolute value x minus c gonna be less than r, converse, absolute value of x minus c greater than or diverse. If x minus c equal r, we cannot decide this series converse, diverse. Let's visualize this theorem. We're talking about theorem of convergence of power series. We're gonna introduce radius convergence. So we call R, that's called radius convergence. So what is the first possibility for convergence of power series? Series gonna be converged only one point. So which meaning is R is 0. Only one point. So I visualize C is the center, only x is c, the series converge, radius gonna be convergence gonna be 0. Other x value, x is not c, or x value right side, that's diverse. X is left side to the c, that's also diverse. That's what we call radius convergence is 0. Second possibility we talk about is series gonna be converged for all real number. That case, radius convergence gonna be infinity. Let's draw the number line. Center gonna be c. All real number is converged. Right side converge, left side converge. That case, radius converge is infinity. Another case is series converged. Absolute value x minus c less than r. Absolute value x minus c greater than r, diverse. Let's draw the number line. R should be between 0 and infinity. Then center is c. What is mean by absolute value x minus c less than r? Which meaning is you have radius is r go to the right, r, that gonna be here. That's end point gonna be c plus r. That red interval gonna be converse. Also, left side, go to the r to the left. We see end point gonna be c minus r. That's gonna be converse. Between the c minus r, c plus r, c is gonna be converse outside. Here, diverse, outside. Here, diverse. Another meaning is x value is greater than c plus r, diverse. X value gonna be less than c minus r, diverse. Please remember that the radius convergence only 3 cases. R equals 0, series gonna be converged only 1 point. R is infinity, series gonna be converged all real number. R is between the 0 and infinity. Series gonna converge between c minus r, c plus r. How gonna find the radius of convergence? If you know radius of convergence, we will know which x value make this series converge or diverse. So here is the good news. We're gonna use ratio test to find the radius of convergence. What is ratio test, guys? Ratio test gonna be ratio of consecutive terms. So we find an, that's the xn, an plus 1, xn plus 1. Let's do ratio test. L gonna be a limit an plus 1 over an plus 1 gonna be xn plus 1, an gonna be xn. So now xn plus 1, that's a separate. Xn plus 1 gonna be x times xn. So we can cancel out xn here. We have absolute value of x. So absolute value of x does not have n term. This one is just absolute value of x. So let's review ratio test. Ratio tests say this L value is less than 1, series is gonna be converse. If absolute value of x, L value is greater than 1, this series is gonna be diverse. Looks familiar, this term? From the theorem of convergence of power series, say absolute value of x minus center is less than r. Series is gonna be converse. What is r here? R should be 1. That's we're gonna find the radius of convergence. Let's have a second exam to find the radius of convergence. So we're gonna use a ratio test. An gonna be x minus 2 to the nth power over n. An plus 1, x minus 2, n plus 1 over n plus 1. We want to calculate ratio an plus 1 over an. We practice a lot ratio test, right? So here is, first term is an plus 1 term. Second is 1 over an. Now, what do you have? You switch the spot, n x minus 2, n plus 1. That's gonna be n over n plus 1, x minus 2, n plus 1 over x minus 2, nth power. So rewrite x minus 2, n plus 1th power, x minus 2, x minus 2n, x minus 2n. I dropped the absolute value because n over n plus 1 is positive. Now simplify this form. So cancel out x minus 2n's power. We have n limit n over n plus 1. X minus 2 should in front of limit because x minus 2 term doesn't have n. So another one is very careful here. X minus 2, you cannot drop the absolute value because we don't know this is positive, negative. Find the limit of this. We can use L'Hopital rule. This limit is gonna be 1. So we have absolute value of x minus 2. Now, ratio test say L is absolute value of x minus 2 less than 1, series gonna be converse. What is R here, guys? What is R? Absolute value x minus center is 2, less than R, series gonna be converse. So R value gonna be 1. That's you're gonna find the radius of convergence. Let's have another example to find the radius convergence. This is power series. We still use ratio test. An gonna be n factorial xn. An plus 1 gonna be n plus 1 factorial x to n plus 1. Let's calculate ratio. So this gonna be n plus 1 factorial x n plus 1 over n factorial xn. We already know n plus 1 factorial gonna be n factorial times n plus 1, xn plus 1 gonna be x times xn. So this is n plus 1 factorial, this is xn plus 1. We can simplify this form. N factorial cancel out, xn is gonna be cancel out. Now what do you have? We have n plus 1 times absolute value of x. So I take it out absolute value of x in front of limit. You have absolute value of x, limit n plus 1. Where this going? And approach to infinity. This sequence going to infinity. So we're gonna put absolute value of x times infinity. This is increasing, guys. Then that's the problem here, guys. We want to find which x value make this is converse. That's L value, F3 value times infinity should be less than 1. Which x value make this one is less than 1? You have only one value. Make this one is less than 1. It should be what, guys? It should be x equals 0. X equals 0, 0 times infinity. That's make this is less than 1 because this value is 0. That case, what? This series, power series converts only 1 point. Radius gonna be 0. Let's make sure it. We're gonna have another example with different radius. So we have another power series. We wanna find the radius convergence. An gonna be xn's power over n factorial. An plus 1 gonna be xn plus 1 over n plus 1 factorial. Let's find the ratio. Here is an plus 1 is xn's power n plus 1 factorial. An gonna be reciprocal n factorial over xn. So xn plus 1, x times xn, n plus 1 factorial, n plus 1 times n factorial, cancel out n factorial, cancel out xn. What do you have here? We have absolute value of x over n plus 1. Absolute value of x gonna be taken out in front of a limit. Then we have absolute value of x limit 1 of n plus 1. Where this limit, what is this limit? That gonna be 0. So absolute value of times 0. So based on the ratio test, L value is absolute value times 0. This always 0. This always less than 1. No matter what x value gonna be, this series gonna be converse for all x. In other words, R gonna be infinity. We studied 3 different radius convergence. R is 0, R is infinity, R is between 0 and infinity. We're gonna study in this slide interval of convergence. Previous slide, we study how to find radius convergence by using the ratio test. Here is the series with radius of convergence. Radius convergence, one meaning is this power series center is 0, absolute value of x minus center, that's the 0, equal, which meaning is absolute value gonna be absolute value of x less than 1. What do you mean by that? So absolute value of x less than 1, this series converge. So this one is number line, center is 0, radius gonna be 1, go to the right to 1, and the point is 1. This red interval, this series is gonna be converse. Go to the left, and the point gonna be negative 1. This interval, negative 1 and 1, this series converse. Another send notation, x gonna be between negative 1 and 1, this series converse. Outside of this interval, series gonna be diverse. What is problem about convergence here? We don't know x equal 1, this series converse. X equal negative 1, this series is gonna be converse or diverse. Let's check it out. X equal 1, x equal negative 1. We have plugged in this number into the series. So series gonna be xn, x equal 1, that's gonna be 1 over n. Then expanded series gonna be 1 plus 1 plus 1 plus 1, which meaning is this series diverse. At x equal negative 1, this series is gonna be x equal negative 1. Here is negative 1 nth power. This is alternating series. 1, negative 1, plus 1, negative 1. This series also diverse. So what is interval of convergence? We're gonna say endpoint is diverse. Now we have interval of convergence gonna be negative 1 and 1. Negative 1, 1 is not included in the interval of convergence. Here is another example to find the interval of convergence. We have power series with radius is 1. What is the center? Center is 2. So we can write this one. F's value of x minus 2, center is 2, less than 1. This series is going to be converse. So draw the number line. 2 is the center. Radius gonna be 1, go to the right 1 unit, that's endpoint 3. Go to the left 1, endpoint gonna be 1. So we're gonna say on the interval 1 and 3, this series converse. Another way, x value between 1 and 3, this series converse. So outside of this interval diverse, no problem. But problem is x equals 3, x equals 1. We have determined if this power series converse diverse. So x equals 3. Let's plug in x equals 3. 3 minus 2 is 1. 1 nth power is 1. So you have 1 over n. So this is harmonic series, this is diverse. At x equal 1, summation x minus 2 to the n, 1 minus 2 is negative 1. You have negative 1 to the n over n. This is alternating series. Alternating series test, they're gonna say this is converse. So what is interval of convergence here, guys? 3 is x equals 3 diverse. X equals 1 converse. So we have include 1 in the interval. So interval of convergence is bracket 1, 3, parentheses. Let's say another example with radius convergence is 0. So this power series has radius convergence is 0. What is mean by that? Which meaning is f3 value of x minus 0, f3 value of x gonna be 0. To the number line, center gonna be 0, radius gonna be 0, that's gonna be only 1 point. What is the interval of convergence? Only 1 point is 0. So how can write it? Interval of convergence, only 0. Let's have another example with radius convergence infinity. This power series radius convergence is infinity. What do you mean by that? Radius convergence infinity meaning is this power series converges for all your number. To draw the number line, center is 0, radius convergent infinity is this series converges all real number. So how can write the interval of convergence? Negative infinity to the positive infinity. Let's have put together what you learned in this session, guys. Find the interval of convergence of following power series. This power series center is 0. So we have find this is center is 0. This is coefficient. Then we have find the interval of convergence. Which x value make this power series converge? First thing is you have to find radius conversions by using ratio test. So that's what we have to do first. Radius of conversion is going to be absolute value of x less than r because center going to be 0. How going to find the radius of conversions? We're going to use ratio test. So an going to be negative 1n's power xn over 2n. An plus 1 going to be negative 1n plus 1 xn plus 1 over 2n plus 1. So find the ratio of consecutive term. So now, first one is, this one is an plus 1. Second is reciprocal an. So similar term put together, we have negative 1 to the n move here. 2 to the n plus 1 move to the right below the 2 to the n. xn plus 1 move to the n above the xn. Now, let's separate each term right here. Absolute value negative 1, n plus 1 over negative 1, n, 2 to the n over 2n plus 1, xn plus 1 over xn. First term, this one is 1 because absolute value of negative 1 to power always 1. That's the 1 and negative 1. So that's gonna be 1. Now let's simplify this one. So 2n plus 1 gonna be 2n times 2. xn plus 1 gonna be xn times x. You can cancel out 2 to the n, x to the n. So you have limit 1 over 2 times x over 1. So you have take out number because they don't have n terms, and you have limit absolute value of x. Absolute value of x doesn't have nth term. This is gonna be 1.5 absolute value of x. This one is by ratio test, this should be less than 1. But we wanna look for R value. R value gonna be absolute value x less than R. So how gonna find the absolute value of x less than R? We have times 2 here. So absolute value of x gonna be less than 2. R gonna be 2. So we find radius of convergence for this power series R gonna be 2. How gonna find the interval of convergence after R gonna be 2? If you found radius convergence gonna be 2, we know the interval absolute value of x less than 2, which meaning is 0 is the center, go to the right to 2, which is end point gonna be 2, go to the left 2, and the point gonna be negative 2. So we have interval of convergence from the radius convergence negative 2 and 2. So we have to check endpoint. And the point gonna be x equal 2, x equal negative 2. So first we're gonna check x equal 2. So we plug in x equal to in power series. Negative 1 and 2, x to n, 1 and n, x to n over 2 to the n. X is 2. So negative 1 to the n, 2 to the n, 2 to the n, 2 to the n, 2 to the n cancel out. So we have summation negative 1 to the nth power. This one is diverse. So we know x equal 2, this power series is diverse. X equal negative 1, we plug in here. Negative 1 to the n, x negative 2 to the n. So negative 1 to the n, negative 2 to the n, that's the same power we're going to put together. Negative 1 times negative 2, That's gonna be 2. So we have 2 to the n over 2 to the n. That's the cancel out. That's gonna be 1. This power series is also diverse. Now, what is interval of convergence? We check the endpoint. Both make this power series diverse. We cannot include endpoint. Interval of convergence is gonna be negative 2 to the 2. On the interval of convergence, this power series converges. What do you learn from this session? First, power series is infinite polynomial center at x equals c. Center gonna be 0. That's the special power series. Second, how gonna find the radius convergence? Or radius convergence you can find by using ratio test. Also, radius convergence tells us how far the series converge from the center. So interval of convergence shows exact set of x value where series converge. Also, you have to use ratio test to find radius of convergence.